In this video we will see what are the expressions that perform actions on texture coordinates or output values that can be used as, or to modify, texture coordinates. Actor position world space outputs vector 3. That is, RGB, data representing the location of the object with this material on it in world space. In this example, you can see that actor position WS is being fed directly into the base color of the material. As a result, each of the spheres with the material applied to them show a different color as they are moved to different locations in 3D space. Note that the result of the actor position WS node is being divided by 1600 to create a nice blend in color, rather than a pop. The camera world position expression outputs a 3-channel vector value representing the camera's position in world space. The preview sphere changes color as the camera rotates. The object orientation expression outputs the world space up vector of the object. In other words, the object's local positive z-axis is pointing in this direction. Now moving the sphere changes the color. One side it's positive with specific color. Opposite side it's negative with black color. The object position WS expression outputs the world space center position of the object's bounds. For example, this is useful for creating spherical lighting for foliage. So in this example, the sphere is in central location with 0, 0, and for x, y and z location. Now moving the sphere changes the color. One side it's positive with specific color. Opposite side it's negative with black color. The object radius outputs a value equal to the size of a given object in unreal units. Scaling is taken into account and the results can be unique for each individual object. In this example, both meshes are receiving this material in which the object radius is fed into diffuse. The object radius output is being divided by 512 to provide a more meaningful visual result. Now in image left where object radius is not fed, both the mesh seems to have different material in terms of size of the tiles. In right image, the object radius is fed. The same material has been fed and the tiling is same. The panner expression outputs UV texture coordinates that can be used to create panning, or moving, textures. Speed x specifies the speed to pan the coordinates in the u direction. Speedy specifies the speed to pan the coordinates in the v direction. Now let's check the inputs. Coordinate takes in base UV texture coordinates. The expression can then modify. Time takes in a value used to determine the current panning position. This is usually a time expression to provide a constant panning effect, but a constant or scalar parameter can be used as well to set a specific offset or to control the panning through matinee or blueprints. Panner generates UVs that change according to the time input. The coordinate input can be used to manipulate the UVs generated by the panner node. So in another example, the panner node along with the texture coordinator has been used to generate some basic water-like material, with some rippling effects. The rotator expression outputs UV texture coordinates in the form of a 2-channel vector value that can be used to create rotating textures. Center x specifies the u coordinate to use as the center of the rotation. Center y specifies the v coordinate to use as the center of the rotation. Speed specifies the speed to rotate the coordinates clockwise. Now let's see the inputs. Coordinate takes in base UV texture coordinates. The expression can then modify. Time takes in a value used to determine the current rotation position. This is usually a time expression to provide a constant rotation effect, but a constant or scalar parameter can be used as well to set a specific offset or to control the rotation through matinee or blueprints. The texture coordinate expression outputs UV texture coordinates in the form of a two-channel vector value, allowing materials to use different UV channels, specify tiling, and otherwise operate on the UVs of a mesh. Coordinate index specifies the UV channel to use. U-tiling specifies the amount of tiling in the U direction. V-tiling specifies the amount of tiling in the V direction. Unmirror U if true. Undo any mirroring in the U direction. Unmirror V if true. Undo any mirroring in the V direction. The Vertex Normal WS expression outputs the world space Vertex Normal. It can only be used in material inputs that are executed in the vertex shader, like world position offset. This is useful for making a mesh grow or shrink. Note that offsetting position along the normal will cause the geometry to split apart along UV seams. The pixel normal WS expression outputs vector data representing the direction that pixels are facing based on the current normal. In this example, pixel normal WS is fed into base color. Notice how the normal map is used to give the per pixel result. Here in this example, the snow on rock is cited with pixel normal and vertex normal, and both the example show how based on pixel and vertex the color or texture variation happens. The world position expression outputs the position of the current pixel in world space. To visualize, simply plug the output into emissive. Common uses are to find the radial distance from the camera to a pixel, as opposed to the orthogonal distance from pixel depth. World position is also useful to use as a texture coordinate and have unrelated meshes using the texture chord matchup when they are near each other. Here is a basic example of using world position to planar map. Without the absolute world position wired, the two meshes shows different. However, when the absolute world position is wired, the mesh seems one, and there is a continuity of same material sheet. Hope from this video, you will start to move into building in more advanced mechanics, in an easy-to-follow step-by-step approach, which will allow you to play around and build your own content, to eventually build your own game. Thanks a lot, see you in the next video.